Let's take a look at solving an inequality that involves absolute value. So here we want to solve the absolute value of 6x minus 6 less than 18. And what we have to realize with a problem like this is an inequality that involves absolute value that meets a certain format is actually a compound inequality. So if I have the absolute value of, let's call this x, which could really represent any algebraic expression, is less than c, and x is an algebraic expression, and c is positive, remember, if c is positive, that means c is bigger than 0. So those are the things that are true about x and c. X can be merely an x, or it could be any more complicated algebraic expression. And c is positive. To say c is positive is to say it's bigger than 0. So if this is true, then that basically means that x is less than c, or, for the absolute value to be less than c, that means x has to be bigger than a negative c and smaller than a positive c. So in other words, in order for x to be less than c units from 0, because remember absolute value is measuring distance from 0. So in order for x to be less than c units from 0, it's got to be between negative c and c. And you could replace this with less than or equal to. So this similar statement would be true if we had an equals to under here. So it's true for less than, absolute value of x less than c, and we would have a similar statement if absolute value of x was less than or equal to c. Then x would be between negative c and c and include negative c and c. All right, so what this does is it allows me, remember, whenever I'm working with a statement that has absolute value in it, in order for me to actively work with the statement, I have to first legally remove the absolute value. So when I see the absolute value of 6x minus 6 is less than 18, I need to legally remove those absolute value bars before I can work on this expression or this inequality. So what I learned above is that the absolute value of 6x minus 6 less than 18 means that 6x minus 6 has to lie between negative 18 and positive 18. We want to isolate x in the middle. So this is actually a compound inequality. And notice that in order for 6x minus 6 to be less than 18 units from 0, that actually means that 6x minus 6 has to lie between negative 18 and 18. All right, and now I'm going to divide by 6. As long as I'm dividing by a positive, I can do it right on this step. If I were dividing by negative, I would rewrite this expression, divide, and reverse the inequality symbols at the moment I divide. So x is between negative 2 and 4 if the absolute value, in order for the absolute value of 6x minus 6 to be less than 18. And so the problem told us to give our answer in interval notation, and that's exactly what we're going to do. We don't include the negative 2 and the 4, but this solution set includes all the numbers between negative 2 and 4. So when if I do a number line picture of this solution set, neither the negative 2 nor the 4 is included, and I simply shade in between, so all numbers that lie in between negative 2 and 4. So this would include 0.95, 1, negative 1, 3.8, the square root of 5, so forth and so on. So those numbers would be included in this set. All right, so this is my solution set for this problem. And the thing to keep in mind is that absolute value, whether an equation or an inequality, if it meets certain conditions, it's actually a compound equation or a compound inequality in disguise. All right, let's take a look at another absolute value inequality. Here, 7 plus the absolute value of 4 minus x over 4 is greater than or equal to 12. So we have another absolute value property that will allow us to rewrite this absolute value inequality without absolute value bars, but such that what we write says the same thing, or is an equivalent statement. So if the absolute value of x is greater than c, x is an algebraic expression, and my c is positive, which to be positive means you're greater than 0. Then for x to be bigger, for the absolute value of x to be bigger than c, means that x is to the left of negative c, or x is to the right of positive c. So to be to the left of negative c means you're smaller than negative c. To be to the right of positive c means you're greater than c. So this is the equivalent way to say absolute value of x is greater than c. And we would get a similar statement for greater than or equal to. So in our case, we are not quite ready to apply what this property of absolute value inequality says to me because my absolute value is not yet isolated. So I need to isolate the expression that has the absolute value. So I'm going to subtract 7 from both sides in order to isolate the absolute value expression. So I subtract 7 from both sides and I'm left with 4 minus x over 4 is greater than or equal to 5. And so using what my property tells me, and notice the connecting word here is or. So 4 minus x over 4 is left of negative 5, which means it's, or it could be negative 5, which means it's less than or equal to negative 5, or 4 minus x over 4 is greater than or equal to positive 5. So I am going to solve this by subtracting 4 from both sides. So I get negative x over 4 less than or equal to negative 9. And then in order to put it in its simplest form, which is another way of saying solve this inequality, I'm going to multiply both sides of this by negative 4. That will isolate x on the left side of the inequality. And I'm going to put this negative sign down with the 4, because remember you have 3 places you can put the negative: with the numerator, level with the fraction bar, or in the denominator. Now because I'm multiplying by negative, if you multiply or divide by negative, your inequality reverses direction. So my inequality is now a greater than or equal to. So these negative 4's divide out to give simply an x, and then negative 4 times negative 9 is 36. So my solution set then as an interval, I have a left bracket because the 36 is included, and then an infinity symbol indicating that I can include 36 and anything to the right of 36 in the solution set, and that basically tells me the absolute value inequality would be true if these are the numbers that I replace x with, 36 and anything bigger than 36. All right, so that's my absolute value inequality. And if I want to graph this, the graph would look something like this. And that would be my graph. Okay, so whenever you see absolute value in an equation or an inequality that you're trying to solve, you have to use the mathematical rules that we've just talked about today to rewrite that equality or that equation or that inequality in an equivalent way without the absolute value bars. and then solve.